Let's dive in. I'm Abe Gong. My background is in data science and data engineering. I've done both tech-first companies like Jawbone and more like classical enterprise companies like Aspire Health more recently. A lot of my work has been around healthcare and kind of human-centric, human-scale data. And uh, not that it's the centerpiece here, but I care a lot about the ethical use of data and just thinking about the impact of data on society. That's me. The reason I'm here today is because I'm one of the core contributors on Great Expectations, which is the leading package for data quality. So my goal in this presentation is to share some of what we're seeing from the Great Expectations community and talk together about best practices, patterns that are working, and then speculate a little bit on the future of where DataOps and data quality goes, because that's what Unleashed is all about. Quick side note, Superconductive is the company behind Great Expectations, and we're hiring, looking for great software engineers and a bunch of other roles. So if you're interested, I'll give you contact information later, but we'd love to hear from you. Quick agenda for today. I'm going to give a brief outline of Great Expectations because we're tackling data quality in a specific way that I think is resonating with the community. I can give you some evidence of that. And then show, kind of using that as a jumping off point, talk about how deployment patterns for data quality are starting to mature. So we're starting to see interesting, consistent, reusable patterns. And I'm going to give at least a high level, start at least a high level conversation in that direction. After that, I'll come back to talk about workflow and how data quality and data ops are fitting together. And for my money, I think that's a really interesting point for discussion. So throughout, I'm going to keep the chat open in the side. If you have clarifying questions, please speak up. It does seem like there is a little bit of a lag between the point when chats are typed and when I see them. So we'll just play that as best we can. That might mean answering inline throughout the presentation. It might also mean just gathering up questions and answering at the end. Either way, we will get to any questions and comments you have. All right, about Great Expectations. So there are several ways that you can attack data quality. We've gone for a direction that is very developer friendly and can fit into lots of different kinds of infrastructure. So the notion is Great Expectations is built on the concept of expectations, which are assertions about data. That can be simple schema-like things like expect column to exist or expect table row count to be between. It can get into the contents of data like uniqueness, nullability, ranges, regexes, string time formats. And it can also get into more kind of statistical process control and ML type things. So expect the column mean to fall in some range, or expect column KL divergence. So KL divergence is a measure of histogram similarity. So you can do things like take a reference distribution for example, training data going into a machine learning model and assert that the features haven't drifted. So it's a really powerful abstraction in the sense that you can expect lots of different things, and they all fit into the same framework and become useful in the same way. And it's not a closed set. The open source library contains several dozen expectations, and it's growing all the time. I'll share more about that later in the presentation. Oh, this is sad. This should be an animated GIF showing how to interact with expectations in a notebook. I guess that the main point to make is we've designed them for a combination of like kind of fast twitch data exploration. So assert this about your data. If it's not true, you get immediate feedback on what are the exceptions and what percentage and so on. Based on that, you can very quickly revise and edit expectations in a manual workflow. We've also done quite a bit of work and have more to come soon on data profilers that allow you to basically point algorithms at your data and generate a plausible set of candidate expectations. We don't believe that you're ever going to be able to automatically generate all of the expectations about data. There's just too much complexity and too much domain knowledge. But there are a lot of things you can do to speed up that workflow and make sure that the developer stays in full control throughout the process. One other thing I should mention, would be nice if we had the notebook, is expectations are set up to be cross-platform. So you can use the same syntax and essentially compile to execution in Python pandas against many different dialects of SQL Alchemy and also Spark data frames. So it's system that can travel across lots of different infrastructure. And I'll say more about that when we get to deployment patterns in a minute. One last thing to note about the way Great Expectations is designed is we've set it up so that your docs are your tests and your tests are your docs. And what I mean by that is all expectations are set up so that they are declarative, which means that you can compile them not just into code that can execute against different platforms, but also documentation in multiple formats, multiple kind of grammars and syntaxes. So that's everything from data dictionaries and lightweight metadata catalogs to Slack messages to, like, we've had teams that have talked about writing emails to data vendors so they can automate the complaining about buggy data. This should animate as well, sorry. But it's a quick screenshot of the out-of-the-box data docs that are compiled from Great Expectations. So just to give you a sense of traction and momentum, we're one of the fastest growing data communities in the world. We've got over 100 people joining the Slack community every month. Starting just over a year ago, we've got over 2,500 Slack members, and lots of the other vanity metrics you look at to understand that an open source project is growing well. So we're really happy. Building in the open for developers is a thing that we love doing, and it's great to see other people diving into that and helping contribute. Just for some sense of the kinds of companies that are exploring and using Great Expectations, it's all over the place. I'd say, and again to the theme of DataOps, there's a bit of a leaning towards companies where data is an operational concern, not just analytics. And we also see plenty of teams that are using Great Expectations for BI and analytics. So I'm going to pause to take my breath. If you have any questions, please jump in. But that notion of expectations as the core unit for data quality is a thing I'm going to talk about more in a few minutes. And hopefully this gives you some foundation as we dive in and start to talk about deployment patterns for data quality. So I'm going to touch on two of these. I looked at it, I was originally thinking of diving in and doing kind of full code, full integration. Given time, I don't think we can go all the way there. So I'm going to stick at the high level diagram level, which I mean, for me as an engineer is a little bit unsatisfying. If you have questions, please speak up. And I'm also happy to point you to additional resources if you want to go deeper on these. Broadly speaking, I'm going to talk about two patterns for data quality. These aren't the only ones, but they're two common ones, and two where you can start to share learnings and compare and contrast pretty effectively. One is data warehouses, the other is machine learning ops. So high level diagram for data warehousing. We've got a pattern from the team at Netflix that they've internally called the WAP pattern, which is write, audit, publish, which we think is great. They've barely talked about it in public, which I think is a shame because I think it's a pattern that should be used more often. But the notion is very often you'll have source data that needs to be validated at that point to understand, is it complete? Is it fresh enough? Does it adhere to the schemas that were previously agreed on with upstream vendors or upstream partners? From there, very often you'll extract that and load it into a staging environment. From there, you'll do transformations on it. And if all of that works and all of that passes, then you want to promote the data through to production where it goes in the data warehouse. Now, interestingly, when you look at the architecture behind this, sometimes steps, let's call this step 1, 2, 3, 4, sometimes steps 2, 3, and 4 are happening within, say, Snowflake or BigQuery. Sometimes it's just step 4, sometimes it's step 3, kind of depends on whether you live in the ETL world or the ELT world. Either way, the notion that you want gates and checks on your data as it goes through, that's pretty common. And you want to be able to support all of those. Another question that comes up here a lot of the time is what tools and what systems do you use? I'll talk about that more in a bit, but we're starting to see an emerging stack where you have a tool that you're using for your business logic and transformation, separate tools that you'll use for extraction and staging, and then very often scheduling or metadata management around that. Yeah, I'll talk more about that in a few minutes, but it's really interesting to see all of the different tools that are emerging and how they kind of carve up the space differently. from our perspective as a data quality tool, what we're saying is we need to integrate basically everywhere because data quality is a concern basically everywhere. And so we're setting up our system to be able to do that. I'm going to definitely play nice and with a very broad cross-section ecosystem. Okay, like I said, if you're an engineer, this is probably a little unsatisfying, but I'm happy to go deeper in Q&A. And hopefully this notion of a WAP pattern and the idea that you want gates at several points, I hope there's enough kind of suggestive information here to think through architecture. Let me talk about another workflow. So this is more workflow than architecture, but you can kind of imagine what the architecture would be behind it. This is a fairly typical flow for machine learning ops. And one of the things that's really interesting about machine learning ops is your workflows take place on different cadences. So data prep happens on one cadence, model development often happens on another cadence, and then production deployment and monitoring happens on a third cadence. Let's see, I'm seeing a question in chat. I'll come to this in just a moment. Let me discuss machine learning ops, and then I will answer that question and any others that come up. So in order to serve that, similar to what we saw before, there's several different points in this workflow where you would typically want to put in validation checks. So one is data ingestion, and you'll see that very often, like these seams between teams where team A produces data and team B consumes data. Very often that's a point where you want data validation, just because it's in many ways the simplest way for those teams to stay on the same page. And I'll talk more about this in a few minutes. Data cleaning, similar thing. We like to dismiss data cleaning in the data world, but I think it's no secret that that's where a lot of the work is. And frankly, that's where a lot of the complexity and business logic is. So for whatever reason, the world of data science has grown up in a way that really lionizes AI and machine learning and the algorithm. But in many ways, those are the things that are more commodity. When you look at what needs to be built out, the specific domain logic for each individual model or each individual business, a lot of it lives here in data cleaning. So because there's a lot of business logic there, you often want to have a thick layer for validation there as well. Feature engineering, similar thing. And then coming out of features that go into your models, you often want to validate the model output, just because that's the last point of contact before it goes to the end user. So at each of these stages, there are different types of things that you might want to look for. So for example, in data cleaning, pretty common to do deduplication and ensure that the kind of data coming in fits certain schemas. So uniqueness and schema checks become really important here. For feature engineering, you often want to look for sets and ranges and ensure that your features aren't drifting and fall into expected ranges. And then for model output, very often what you're looking at is histograms or distributions, and just verifying that the model is doing roughly the same thing today that it was doing last week, so that whether or not it's a data quality issue or maybe just some underlying trend in the real world, you understand if your model is out of band from the domain on which it's trained. So let me pause for just a second, open it up for questions. So one question is, best practice for data validation process. Should it be a parallel process or part of the ETL ingestion workflow? And I think this question was asked a couple slides ago here. The short answer is we see both in the Great Expectations community. So we see, and we've given them names. One, the first one as a parallel process, we'd usually call data at rest. And the notion there is you push data all the way through until it's essentially published and complete, and then you validate it there. The second pattern is what we typically call data in motion. So you're actually putting checks into your Airflow or your Spark DAG. Again, there are pros and cons on both sides. We tend to see teams starting with the first, so validating data once it's been moved in. Of course, the problem there is if there's bad data, it's already flowed downstream and possibly caused problems elsewhere. But there are a lot of data teams that only have read access to those systems or for compute reasons, just have trouble enforcing compute gates all the way up. So often it's easier to deploy checks against data at rest. But over time, we tend to see this shift left where teams start putting in more and more checks earlier in the process so that they can catch problems before they propagate. Second question, how do you adjust expectations to account for data drift? There are actually a bunch of different ways, and the right answer depends very much on context. In some cases, what you want to do is just put fixed bounds in and assert that you haven't drifted outside those bounds. And the reason that you want to do that is if you have a static model that's trained on certain data, if the range of data that's being modeled later on or predicted upon later on deviates strongly from where it was trained, that's probably a trigger to go back and re-examine some of the assumptions that went into the original model. On the other hand, we do see teams where they're adjusting for seasonality, or they have a fairly simple case is an upward trend in the data, and they want to assert that you haven't had too big of a change since last time. In Great Expectations, we have a notion of evaluation parameters, which essentially lets you put in not fixed values, but variables pulled from previous evaluation into expectations. And that allows you to account for things like trends and drifts and seasonality. And I'll say that's very much an area of active exploration and development. So if you have feedback and ideas there, it's a place where there's actually quite a bit of technical depth, and we're excited about working with more people to well, I'll say more on this later, but to essentially develop a common language for describing and thinking about those problems. All right, one more question from Q&A. How could be a design pattern for some code to include the validation process? Would it be like some traditional software test folder and assertions? That's a great question. So again, we see multiple patterns here. The one that I think is most common is to store expectations like test fixtures and metadata, and then apply them kind of like monitoring rules. We do see teams that are using expectations to test the code itself, but because most of these systems, you deploy the code once and then the code doesn't change very much, the data changes frequently, like every hour, every day, or every new batch. We think it's very important to make sure that you're testing changes in the data, not just changes in the code, because that's where you're more likely to encounter like bugs and issues and just unexpected things. In terms of storage, you can put them right in source control, and we've set up Great Expectations, so that's pretty easy to do. If you are using these test fixtures more like metadata and collaborating on them with other people outside the team, it can often be useful to actually put them in a store, more like a model store or feature store, so that other people can collaborate on them and edit them together. Okay, hope that answers questions. We'll do another round at the end. Let me move forward and just talk about a handful of trends that I'm seeing coming out of the data quality and DataOps movement. And again, I'm interested in everybody's feedback. I think we have an interesting and unusual position in the Great Expectations community, just because we see so many use cases coming together here. So one trend, unlike observability and monitoring in the software engineering world, data quality faces out from engineering. And what I mean by that is, if you look at tests or observability or those tools and how they're used by software teams, in general, the only teams that really dive into the logs or really dive into the tests are the teams who are, people working on the product itself right now. It's very rare to see external stakeholders really diving into tests or really diving into observability platforms. In the data world, exactly the opposite is true. I mean, what we see is there are lots of other stakeholders. We tend to lump them together under this heading of domain experts, but those could be operational folks. They could be people in finance and accounting who are very data heavy, but mostly use spreadsheets and are less likely to use code. But there are all of these collaborative workflows that must involve other people who aren't code writers. So the way we like to say it is data quality is an external facing function, not an internal facing function. And that's different from software. It's a place where DataOps is just going to be fundamentally different from DevOps, for example. I've got my slides slightly out of order. Let me skip through. The way we like to think of it is DataOps is really made of two skill sets coming together. One is repeatability, which is the kind of software engineering skill set, and then the other is domain expertise. And when you think about all businesses becoming data businesses, the work of doing that, like the work of translating the specific domain knowledge and business logic for any given company into repeatable data processes, is right in the middle of that Venn diagram. Okay, second trend, because you have this rich collaboration between coders and non-coders all collaborating around data, over time, what we see is that every organization's data quality layer starts to become a rich shared language, a language that by definition has to cross team boundaries. And just to give you some sense of what that looks like, I want to go through and just review some community contributions to the language of expectations. So recently we've seen contributions of things like expect column values, number of decimal places to equal. So like how many decimal points are there in this column? Other things, column values to match an XML schema or to be EDTF parsable. So these things are kind of like more engineering concerns, although you can see how the first one might be an accounting concern. Expect column values to be US zip code within radius of given zip code. That one feels very operational to me. We're saying, okay, we have a column that contains zip codes. Are they close to reference points? Like, is this people who live close to Starbucks? Or I actually need to go back and see who contributed this. But you can see how this is more of an operational concern. Expect column to match Benford's law. So we're doing some fraud detection here, probably. And then some internet security things. Expect column values to be secure passwords. It's interesting to think about how you define secure here and various services you could call out to verify that. Expect column values to be non-bot user agents. So this is just kind of a grab bag. I actually picked these up last night of recent contributions to the library. But the thing that I want to point out is a lot of all of these very much pertain to data quality. Not all of them are what we would think of as engineering concerns. And we see this as indicative of this notion of expectations growing to be a rich shared language between all the stakeholders who need to collaborate around data. When you look at the Great Expectations community, the number one request is for more expressivity. And one of the things we're pushing hard on is making it so it's easier for members of the community to build and contribute these back, because we see a lot of richness growing here. Third point, because of this, data quality has to integrate with tools at every level of the DataOps stack. And that's everything from databases. So, I mean, we integrate with all of the major SQL engines, especially the data warehouses, Snowflake, Redshift, BigQuery, Microsoft SQL Server, also Spark, also Pandas. We're starting to see people talking about a DAGs stack, and I love this acronym. It's not totally clear what the acronym is going to stand for. So I've had some people say it's DBT, Airflow, Great Expectations, Snowflake. I've had other people say, oh, no, it's Databricks, Great Expectations, Spark. We're agnostic. We want to fit in just about everywhere. But the notion that there's going to be an emerging stack and that data quality will be an important layer, both in terms of validating along the way and then also throwing off really useful metadata for other processes, it is really important. I think the evolution of the metadata landscape is going to be really interesting. It's one of the main things I'm interested in kind of getting out of this conference, listening to other tools and other providers. And it's worth mentioning, just because our hosts here are coming from Unravel, we're also actively looking at integrations with Unravel and making it so that Great Expectations can be a first-class citizen in that ecosystem. All right, last trend, and this one I think is early, but I'm going to go out on a limb and make this a prediction. If you look back to the period when CI/CD was catching on, 15 years ago, plus or minus, there came a time where people would ask about CI/CD in interviews, and you could ask various ways, like, oh, well, what's your CI setup like at this company? But what employees were really asking, or prospective employees were really asking is, hey, is this one of these places where you don't have CI and everything is always on fire? Or is this, going to be a good place to work? And we're already starting to see people put Great Expectations in their resume. and starting to see companies that will blog about their data quality and how they're approaching it. I'm going to go out on a limb and say 2021 is the year where data quality becomes a priority for morale and retention, where there just starts to be a big dividing line between working in an environment where the data platform has lots of technical debt, and so it's impossible to plan ahead and you're always putting out fires, versus places where you have good data quality in place, and so you can scale predictably and build predictably. I might be off by a little bit, but it feels like we are reaching that point in the adoption curve and the awareness curve around testing and just paying down pipeline debt. So 4 trends. I hope there are useful things to latch onto and respond there. Let me open it up again for questions. And while you add questions in chat and QA, I'm going to keep talking through just a few final points so that we don't have to wait at the end of the presentation. But you know, if we were all in person, this is the point where people would be standing up and coming to microphones. Well, that's coming together. More resources. So I know that I was a little bit light on engineering details, especially for deployment patterns. If you go to greatexpectations.io and especially check out the blog there, we have more on both of those patterns and several others, plus integrations with tools and just a fair amount of discussion around best practice in this space. We're also very responsive in Slack, so feel free to jump in there, ask questions. You can find me there and DM me. And if not, other members of the team and community will be happy to answer questions. Beyond those resources, we are also actively working on partnerships at Great Expectations. So we love integrating with other open source tools, or just data tools in general. It doesn't have to be open source. So if you're like that, if you're active in the ecosystem, please reach out. We can figure out how to integrate. We're also starting to work towards an enterprise advisory board. So if you're coming from a company where data quality is a major concern and you'd like to collaborate and help shape where Great Expectations goes, also please reach out to me. And just full disclosure, we're an open source tool, we're venture backed, so we will build a commercial layer on top of the tool eventually, before too long. And as part of that, our commitment to the community is everything that is in Great Expectations now will always stay open, and will always be a developer first tool, especially as you get into this layer of collaboration and building on top. We see lots of opportunities to just build tools and additional software to make the whole world work better there. Let's see, I am seeing one question. Is there a GitHub, a place where there is case studies? Yes, it's a little bit hard to give the GitHub link because they have underscores and hyphens, but if you go to greatexpectations.io, in the header, it links immediately to the GitHub. Cool. Thanks, everybody. You know where to reach me. Hope to see you soon.